Let f is a function of x equals 1 plus 3 secant x, and g is a function of x equals negative 5. In the xy plane, what are the x-coordinates of the points of intersections of the graphs of f and g for the domain 0 is less than or equal to x, less than 2 pi? Okay, so anytime we're dealing with points of intersection, we want these two functions to be equal to each other. So let's set up that equation. 1 plus 3 secant x equals negative 5. So we solve for x. We're going to subtract 1 on both sides. And so we have 3 secant x equals negative 6. Divide 3 from both sides, and we have secant x equals negative 2. Now, secant is the same thing as 1 over cosine. And so I want to solve for x, so I'm just going to write the reciprocal of this. And so 1 over cosine x, the reciprocal, is cosine x. And so since I did the reciprocal on the left side, I'm going to do the reciprocal on the right side. So the reciprocal of negative 2 is negative 1/2. So looking at cosine x equals negative 1/2, I think about the unit circle and the quadrants. All students take calculus. So that's a easy mnemonic device to help you to remember what is positive in that quadrant. So all means everything here is positive in the first quadrant, but remember we have a negative, so I'm going to cross this out. Also, C, it means that cosine is positive in this quadrant, but it has to be negative. So the only two quadrants I'm thinking of is quadrant 2 and quadrant 3, because only sine is positive in quadrant 2 and only tangent is positive in quadrant 3. Okay. Now, before I continue, I know in our AP Precalculus course, you never talk about degrees, but it's easier in the brain to remember that cosine 60 degrees is half. And so what would 60 degrees be in radian format? Pi over 3. And for you to remember, basically 3 times 60 is 180. Okay, that's how you remember it. So pi over 3 would be somewhere over here. So when we think of like the unit circle, which you should have memorized, it goes by pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And remember, the reason why I'm counting it this way is because I need to have a fraction that has a reduced form such that the denominator will end up 3. And 4 pi over 6 actually becomes 2 pi over 3. So I'm going to cross this out because that's not our answer. So far I have 2 pi over 3 is a possibility from the second quadrant. So let's continue. So it was pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. Now, while I'm counting this, in my head, I'm calculating which one will reduce to have a denominator of 3, and that's 8 pi over 6, which reduces to 4 pi over 3. So our next answer would be 4 pi over 3. So what is our answer? We have 2 pi over 3 and 4 pi over 3, which is choice C.